Hi there everybody, just another math school video. Today we're going to look at adding and subtracting algebraic fractions. Relatively, I say it's relatively straightforward, but you might find it a bit more difficult. Really we're going to look at adding and subtracting normal fractions with a bit of algebra in there. So you need to be able to add and subtract normal fractions. I will go through what that process is, just as a reminder. But we also need some algebra skills in there where we're probably looking at expanding your brackets and simplifying. All right, but like I said, we'll go through a few examples, and then if you're feeling a little bit short in terms of other aspects, then you probably want to have a look at some other videos that kind of cover those kind of things. But let's go through this. Okay, so in order to add or subtract fractions, we first need a common denominator. All right, that would be the same for any fraction, algebraic or otherwise. All right, so let's look at an example. So we've got 3 over x plus 5 over x plus 1, all right? Might look a little bit complicated in terms of what you need to do, but the process is relatively straightforward as long as you stick to that process. We need a common denominator. Well, if you think about a normal fraction, and if you're aware of what you do with the normal fractions when we add, we need to have a common denominator. Well, these denominators are both different, okay? One is one more than the other, all right? So if I took an example of 3 and 4, if I wanted a common denominator with 3 and 4, I would times the two together, and that's going to give me a common denominator of 12. But of course, we don't know what these numbers are because we've got an x and an x plus 1. So the only thing that we can do is just times them together as they are. Okay. So what we're going to do is I'm just going to highlight the one in green and the other one in purple so that you can see them clearly. And then I'm just going to talk about what we're going to do with each. Right. So the denominator are x and x plus 1. So we need to times this one over here by that one, and that will give us a common denominator. Okay, so x times by x plus 1. If I'm going to times this one by x plus 1, whatever I do to this bottom number here, the denominator, I have to do exactly the same to the top to keep it equivalent, the same value. All right, if you imagine 1/2, 2/4, 3/6, 4/8, they're all halves, but of course they've got slightly different numbers. So if I'm going to do something to the bottom, I have to do the same thing to the top. So I'm going to times this whole fraction here, top and bottom, by x plus 1. All right, and I'll write that down. So multiply it by x plus 1, top and bottom. And then I'm going to do something very similar to this fraction over here. But rather than times it by x plus 1, I'm going to times it by the denominator of the other one, which is the x. Okay, so I'll write that one down so you can see it. So I'm going to multiply it by x. All right, so that's our first step. We're going to try and get a common denominator, i.e. that times that, so that we can add them properly. Okay, so let's see what we've got when we do that. So we have multiply this first one by x plus 1, so 3 bracket x plus 1. All right, we put a bracket in there just to remind ourselves that when we're doing 3 times by the x plus 1, it's 3 times both of these two things and not just the 1. All right, 3 times x and the 1. At the bottom, that's going to be x times by x plus 1, and that's going to give our first fraction. Don't need to do anything with it at this point, just leave it exactly like that. We're now going to do the same process for the second one, this one over here, but we're going to times it by the x. All right, so that's going to times by the x, and both of these two are going to times by the x. All right, and hopefully you can see that we've done here. So 5 times the x, and the x times the x plus 1. All right, and you'll notice now that these two numbers at the bottom, denominators at the bottom, I should say, are both the same, and that's what we were trying to achieve. We're trying to get these two to be the same so we can add the top two. Right, so this is where our algebraic simplifying expressions kind of comes into play, because we need to simplify this top lot. All right, so our first step really is expand this bracket. So when I times the 3 by the x, that gives me 3x's. When I times the 3 by the 1, that gives me 3. And of course it's a plus, so 3x plus 3, and then we're adding the other 5x, the 5x. And now our denominators come together, and it again remains the same. So we have x bracket x plus 1. We now just, and as a final step, we just look to simplify it, because that's what it said in the question, simplify. Well, we've got 3x's and 5x's, that's going to give me 8x's. And we've got a 3 on its own, plus 3 over x's plus 1. And that's it, it's done. Okay, I've simplified them, I've brought two fractions together. You could argue it looks more complicated, but it is then now one term as opposed to two separate terms. Right, does it work with subtraction? Of course it does, it's exactly the same process. You've just got to keep your eye on the minus in the middle and what that does when we simplify at the end. But the process should be the same. So we're looking for a denominator of x over x minus 3. So I'm going to take the x minus 3 and times it by these two, which is going to give me that lot. So 6x minus 3 over x minus 3. We're going to take these two and times it by the x, again, top and bottom. So it should give me this lot, so minus 2x, x minus 3. And you can see denominator is the same. And then this is where we want to try and skip a little step a little bit. I'm going to try and expand this in my head and see what I get. So that's going to give me 6x minus 18 and take away another 2x. Well, 6x minus 2x is 4x, hope you agree. And it's going to give me minus 18 on the other side. So there you go. So 4x minus 18 over x minus 3. I like the one above. Nothing else I could do with that. That's my job done. Okay. Thanks for listening.